Hey guys, what's going on? Today we're going to be looking at 12.7 and 12.8, volume and surface area of similar solids. So similar solids have exactly the same shape, but they are not the same size. Two solids are similar if the ratios of their corresponding linear measurements are equal. Linear measurements is a very fancy way of saying sides. So basically their corresponding sides are equal. So for example, it says determine whether the solids below are similar. If yes, give the scale factor in the simplest form. All right. So basically you're going to compare their sides to one another, but they need to be corresponding sides. And in this case, it does not say uh, which shape or solid you're going to from the other. So essentially, the way you set up the ratio does not really matter as long as you stay consistent. So I'm going to call this one A and this one B. So for all my ratios, I'm going to do the side of A over the side of B. Okay. And by this, I'm naming the entire solid, A and B. So first, clearly these two guys are corresponding sides. They're both height. So let me do 12 over 3. That's 4. Okay, now I'm looking at the base. Okay, well 2 is my smaller number between 2 and 5. 8 is my smaller number between 8 and 20. So now I do 8 over 2. That's 4. So look at the last one, 20 and 5. So 20 over 5 indeed is 4. So yes, these are similar solids and the scale factor is 4. Okay, remember, you have to check for all sides in order to verify that they are similar. Okay, let's take a look at the next one. Okay, since this is a square, uh, since the base of this prism's, they're a square, we don't need to do 6 over 10 twice. Again, saying we call this one A and this one B. So we can just do 6 over 10 once. That simplifies to 3 over 5. Now let's take a look at 8 over 12. Okay, and 8 over 12 simplifies to 2 over 3. Okay, so no, these are not similar solids. Their scale factor for corresponding sides are not the same. Okay, so if two similar solids have a scale factor of A to B, then their volume and surface area ratios are as follows. We've looked at this before, but we weren't talking about surface area. We were talking about area of the entire shape was A squared to B squared, and it's the same for the surface area of a solid. Just keep in mind, right now we're in the 3D world, which is why we're kind of restating something that we've seen before, but it's slightly different because now we are talking about surface area, not just the area of a two-dimensional shape. We're talking about the surface area of a three-dimensional shape. So speaking of dimensions, you know with area, your units were squared. This ratio is A squared to B squared, so you might be able to guess or deduce that for volume, it would be A cubed to B cubed. So let's take a look at some examples. I'm not going to fill out this whole table. I'll just do 2 or 3. I'll start with the first one, easiest one. The ratio of our corresponding sides is 5 to 8. So that means the ratio of the areas is 5 squared to 8 squared, which just expand that. That's 25 to 64. So the ratio for volumes is 5 cubed to 8 cubed. You might have to do that in a calculator. That's fine, but that's 125 to 512. Okay, the next one I want to do is this one. The just immediate next row. So again, this is a cubed to b cubed. Okay, which is also this part right here. We've already set it above. So that means in order to get a and b, so a is the cube root of 512, and b is the cube root of 1728. Okay, you're gonna do that in the calculator. You hit Control and then the caret button, which is right under the equal sign, and it'll open up a box that looks like this. 3 goes on that outside box, and then your number goes in here. Again, you need to remember that because some of you might put this in your calculator where it's 3 square root of 512. That is not the same as the actual cube root of 512. These are two very different things. But regardless, doing that in your calculator ends up giving you 8 to 12. Cube root of 512 is 8. Cube root of 1728 is 12. Okay, so again, that's a to b. So then ratio of areas is a squared to b squared. So 8 squared is 64. 12 squared is 144. Okay, next one I want to do is this guy right here. So don't forget, and this is the only reason I'm choosing to do this one, don't forget, especially on your A to B, always simplify your fraction or ratio before you start getting the ratio of areas and volumes. So 66 to 18. Again, view that as a fraction, 66 over 18. Clearly, that can simplify. I say clearly because, well, they're both even numbers, so you can for sure start by at least taking a 2 out and then see where things go from there. Okay? Or in your calculator, if you allow it to simplify for you, you'll notice that basically the greatest common factor here is 6. We can take out a 6, and this is 11 to 3. So now this is 11 squared to 3 squared, so that's 121 to 9. And then this is going to be 11 cubed to 3 cubed. Okay, so that goes to 1331 to 27. Okay, I am going to skip this one for the video. I would rather look at something. Yeah, something like number 4. So it tells you that the surface area ratio is 25, or that the surface area for one pyramid is 25 feet squared, and then for the other pyramid, it's 4 feet squared. So it wants us to find the scale factor ratio, meaning just for like sides, linear measurements, surface area ratio, volume ratio. Okay, and notice on this, it does not tell us that we're going like from one shape to the other. Like it doesn't specify which way we have to set up our ratio. So that basically just means you have free will. Do what you want. I'm going to do, say this is A, this is B. I'm going to do A over B. Okay, so again, these are my surface areas. That's 25 over 4. Again, that represents A squared over B squared. So really that is my surface area ratio, 25 to 4. You can express it as a fraction. So if you write 25 over 4, it's the same thing. So whichever way you prefer. Okay, so then this means A squared equals 25, which means A equals 5. And then B squared equals 4, which means that B is 2. So this is 5 to 2. And for volume ratio, so we always need to find this one first if we don't have it, because all of our other ratios are in terms of A and B. So we need to get A and B first. And then for volume, it's just A cubed over B cubed. Okay, so 5, I'll just write it, 5 cubed over 2 cubed. 5 cubed is 125, 2 cubed is 8. So we got 125 to 8. Okay, I'm going to do one last example. Okay, so let's look at example 6. So cylinder A and cylinder B are similar. Cylinder A has a diameter of 24 feet and cylinder B has a diameter of 30 feet. What is the ratio of the volume of cylinder A to cylinder B? Okay, so now it did specify, it's saying we're going from cylinder A to cylinder B. So I always imagine ratios as new over original. Okay, so if you're going from cylinder A to cylinder B, so uh, if you're going from cylinder A to cylinder B, then that would mean cylinder B is your new one, cylinder A is your original. Actually, scratch that last part. Sorry, it doesn't say from. That's my mistake. It doesn't say from cylinder A to cylinder B. It just says cylinder A to cylinder B, which just means this. So I was overthinking that one. I'm used to the whole from and to thing. It just says cylinder A to cylinder B. So that just means A to B, because that's how you read this ratio anyways. From math notation to English, it's just A to B. Okay, so no problem. It gave us linear measurements, diameter, just meaning it's just a side, it's not area or volume. Okay, and we're doing A to B, which means we could do A over B. So cylinder A has a diameter of 24. Cylinder B has a diameter of 30. So if we simplify that, that is 4 over 5. Now again, this is A over B. It says it wants the ratio of volume. Well, we already have A and B. A is 4, B is 5. So for volume, it's just A cubed over B cubed. Okay, so we got 4 cubed over 5 cubed. Okay, so 4 cubed goes to 64. And 5 cubed goes to 125. Okay, thank you guys. That's it.